great science fiction term, but the fact of the matter is science fiction very often is ahead of science. And, you know, the word ray, it really describes a laser. And the answer is yes, you can use lasers to create very directed beams of light that could have a lot of energy and power in them and project them long distances and hit things and, you know, burn them up.
In fact, there are several real-life laser weapons in development right now. So what exactly is a laser?
This is a laser, right? It's a beam of light that's being transmitted towards you, you know, from a small aperture, in this case, this laser pointer. What's the difference between that and regular light? Regular light is like a mob scene, right? All those, if I look at those atoms, they're putting out light in random directions at their own time and have no idea what the others are doing.
But inside a laser, every atom is perfectly aligned and moving at the exact same frequency along the electromagnetic spectrum. To shed some light on how the technology actually works, we've tracked down some really big lasers here at Lawrence Livermore National Laboratory in Northern California.
This is the solid-state heat capacity laser at Lawrence Livermore. It is one of the most powerful solid-state lasers in the world. You can think of this as a laser pointer on steroids. You take a typical laser pointer, it's a red little beam, and it's about a milliwatt, or 1/1000th of a watt. We routinely run this at 25 million times that. To give you an idea of what 25 million times a laser pointer can do, is we illuminated a piece of metal. This happened in a few seconds. We actually melted a hole and tore the metal out in a few seconds.
Okay, prepare to fire. 3, 2, 1.
In this case, we illuminated carbon steel. This is about 1 inch thick, and again, in a few seconds, we cut right through this like butter.
Inside this laser, a large tube called the optical cavity is fitted with mirrors on both ends. Inside the cavity sits a solid ceramic material. The atoms inside the medium are energized or pumped with a high-energy blast of light. As each excited atom attempts to return to its normal state, it releases a tiny burst of light energy called a photon.
And those photons are trapped between two mirrors. Every time the photon passes through the active medium, it sees gain, so it gets more and more energy. After millions and millions and millions of passes, you have a very, very intense beam of light.
The mirror at one end of the optical chamber is designed to let this intense beam of light leak out. What you won't see is the laser beam itself, since it's vibrating in the invisible infrared range of the electromagnetic spectrum. But will the laser beam finally carve out a place for itself on the battlefield? The answer is yes. Behold, Zeus. Zeus is a lightweight, mobile, multiple kilowatt solid-state fiber laser cannon, powerful enough to burn through metal at more than 300 yards away.
If you ever played around with a magnifying glass when you were a kid, you might take that magnifying glass and get the sun behind it and get it focused so that you had one small little point where you could catch a piece of paper on fire or chase an ant down. Well, Zeus is basically the same way. We're focusing photons from about a 6-inch diameter down to a very small point.
Zeus actually fires 2 laser beams. The first is visible green light, which helps the operator locate the target. Then the more powerful invisible laser is activated. This laser isn't content being stuck in the lab. No, this laser beam is one mean mobile machine.
This is Zeus. It's a high-power laser system on an armored vehicle. We use this to destroy unexploded bombs in the battlefield. On top of the vehicle, you see we have a turret. That turret actually points the high-power laser beam onto an unexploded target, heats up the outside of the case, and causes the explosion. Around the back of the vehicle, we've got a laser cooling system. We actually use this to keep the laser cool while we're firing it. This is the business end of the high-power laser system. This is where the operator sits and fires the laser. We've got a display system that allows the operator to zoom in on a target that's a long distance away. We have a console for turning the laser on and for arming it. And we have the control stick. This allows the operator to zoom and focus and then fire the laser.
But Zeus wasn't built to slice through enemy soldiers. The engineers at Sparta Incorporated designed this laser to protect lives by safely eliminating unexploded munitions, exposed landmines, and even IEDs, improvised explosive devices.
We can destroy targets that are 25 to 300 meters away from Zeus. That's 3 football fields. Excess of 3 football fields.
And seeing is believing.
We're at Redstone Technical Test Center, where we're going to use a high-power laser system to detonate some unexploded ordnance, including an example like I have in my hand. This is a mortar round. The operator who sits in the back of the vehicle is using a camera system to scan the area to look for the item that he wants to destroy. When he's finally found it, he locks in on that, and after a few seconds, boom, it'll be gone. Once you've aimed the laser, it begins to heat up the metal case. And that heat basically causes the explosive filler material that's inside the device to start outgassing and then eventually erupts and blows the case open.
Target is acquired. Bring RPMs out. Fire and tag laser. Fire negation laser. Target is destroyed. 3 seconds on target.
Throughout its testing phase, which included stints in Afghanistan and Iraq, Zeus has destroyed more than 2,000 ordnance devices of over 40 varieties.
Anytime you can blow up a bomb out on a range, watch it explode, it's a good day.
Down the road, Sparta hopes Zeus will become a common sight on the battlefield,
Target destroyed.
destroying hazardous explosives and saving lives. But Zeus isn't the only laser weapon headed for action in the combat zone. Lasers are about to take flight. The Air Force is working on its own laser weapon, the Airborne Laser, or ABL. Mounted on a Boeing 747, the ABL is designed to shoot ballistic missiles out of the sky. This laser is perhaps the most similar to the weapon favored by our fictional alien invaders.
I think the advantage is you're working at the speed of light. You know, things happen for all practical purposes instantaneously.